Should I start? Should I start? Yes or no?
Yes, yes.
Okay. So here we made a statement that this displacement diagram, it will depend on type of the follower motion. Means what kind of motion do you desire to give to the follower? Okay, depending on that, there will be specific construction for the displacement diagram. Okay, so now next topic, let us see that it is motion of the follower. Okay, so there are different types of motion which are possible to be given to the follower. Okay, such that when a follower moves, say, from its position 1 to its position 2, at that time these are the condition of motion. So first case is uniform velocity, that when the follower will move from lowest position to the highest position, it will do so with constant velocity. It will uniformly moving. Its speed will remain same. It is the first case. Second case is that it is also possible that it moves with simple harmonic motion. Okay, what is the simple harmonic motion? To and fro motion, you know already, that a particle has a center position and it has two extreme position, 1 and 2. It is the center position, and particle travel between these 2 points, 1 to 2, 2 to 1, like this. Okay, so what is simple harmonic motion? In this, the velocity, sorry, acceleration of particle is directly proportional to its distance from the uh, center. Are you getting it? Means at particular time, what is the, you know, what is the distance between particle and its center position, that is x. So if particle is away from the center position, its acceleration will be greater, and as it will be closer to the center position, its acceleration will be less. Okay, so at center point its acceleration will become 0. That is simple harmonic motion. Then there is third kind of motion, that is uniform acceleration and retardation. This I will explain you in next lecture. Next is the cycloidal motion. So this will also be explained in the next lecture. Okay. So in this lecture, let us see when velocity is uniform. Okay. Then how to construct the displacement diagram. If the motion is of type simple harmonic motion, then how to construct the displacement diagram. We will see these two cases today. Okay. So motion with uniform velocity. I have already told you that when follower moves from its lowest position to the highest position, its velocity remains constant. Its velocity remains uniform. Okay. So if such is the case, then how to draw the displacement diagram? So first one, you construct a rectangle of height equal to the lift or stroke of the follower and of any suitable length. तो आपको क्या करना है, पहले एक रेक्टेंगल ड्रॉ करना है. ओके. जिसका जो हाइट है, height will be equal to the lift of the follower. Means what is lift? Lift is the maximum travel of the follower. Means what is the distance between its two extreme position, lowest position and topmost position. So this height must be equal to lift of this rectangle, and the length could be of any size. ये length आप कुछ भी रख सकते हो, no problem. Okay. So now next is what? Divide this length of the rectangle into even number of equal parts. मीन्स आपको इसको 6 पार्ट्स में डिवाइड करना है, या 4 पार्ट्स में, या 8 पार्ट्स में, इवन नंबर. Okay, and you have to divide it into equal number of parts. So in this case, let us divide it into 6 parts. So what I will do, I will take this length as 60 mm, so that I can divide the 60 mm into 6 parts, each part being equal to 10 mm. Okay, so I will divide it into 6 parts. So ये हो गया आपका 2 parts. Okay, then ये हो गया आपके 3 parts here. All the parts should be equal, keep in mind. Okay, you have divided it like this. Now you have to number them. So for example, I will start with 0 here. First, second, third, fourth, fifth and sixth. Okay, now next draw the vertical lines. ये vertical lines draw कर लिया आपने. Okay, join the left lower corner with the right upper corner of the rectangle. So left lower corner means here, यहाँ पे, और right upper corner means this point. So you join them with direct straight line. It will be a straight line. You will directly join the two corners diagonally opposite to each other. Okay, so this diagram you have drawn here, your angle is your theta. Excuse me. So here it is your angle of rise, theta 0. Okay, by angle of rise at point 0, the follower is here. When the cam will rotate through this angle 0 to 1, then follower will to this side. Follower will move to this side. When cam will rotate from 0 to point 2, then follower will be at this side. When it when cam will rotate through position 0 to 3, the follower will be at halfway in the middle of its path. Okay. Similarly, you can locate the different position where these vertical lines are cut by this line. Okay. So you get these points afterwards. Okay. So I will call this point as 1 dash. It is 2 dash point. Similarly, this point I will call as 3 dash, 4 dash, then here 5 dash, and here it is 6 dash. In this way, you will draw the displacement diagram for which kind of motion? Uniform velocity. This I have drawn when follower is rising. Suppose if follower is returning, then you will repeat the same procedure, but during return you have to join these two corners. Means initially the follower is at topmost position and it is returning like this. Your diagram will be like this in case of returning period. So it is your angle of return, theta r, it is h. Are you getting how to draw the displacement diagram when you are given the condition of uniform velocity? It is simple, isn't it? Nothing so complicated. Yes or no? क्या किया पहले?
Yes, sir.
यस, ओके। तो पहले एक रेक्टेंगल ड्रॉ कर लिया। रेक्टेंगल का जो हाइट था वो स्ट्रिक्टली किस डायमेंशन का था? दैट इज इक्वल टू लिफ्ट स्ट्रोक ऑफ द फॉलोअर, कितना दिया है उस पर। और लेंथ आपने एनी लेंथ लिया है। ओके, दिस लेंथ सपोज यू हैव टू डिवाइड इट इनटू 6 पार्ट, तो आप 60 mm ले सकते हो। सो यू कैन इजीली डिवाइड इनटू पार्ट्स ऑफ 10 mm लेंथ। ओके, so it is the construction of displacement diagram when uniform velocity is given. Now let us see what are the important formulae of the motion with uniform velocity. So you write down this formula. H तो आपको पता है, H is lift. S is what? S is the displacement of follower at any angle theta. At any angle theta. Okay, theta is nothing but cam rotation angle. It is cam rotation angle theta. What is phi? Phi is either the angle of rise, it is either angle of rise or angle of return. So phi is nothing but your angle of rise either or angle of return. Write it down. Is it done?
Yes, sir.
Okay. So you can see that velocity is constant because we are discussing the case of constant velocity motion. So if velocity is constant, acceleration is what? Acceleration is rate of change of velocity. But there is no change in velocity. Velocity is constant, so acceleration will be zero. Okay. So you know what is the velocity, what is the acceleration. So as you have drawn the displacement diagram, you can also draw the velocity diagram. You can also draw the acceleration diagram. So what will be the velocity diagram? In displacement diagram, displacement of the follower is there on y-axis. So in velocity diagram on y-axis there will be velocity of the follower, and on x-axis as usual cam rotation angle theta. So as cam is rotating, how the velocity is changing with respect to theta. This is called as velocity time diagram or velocity angle diagram. Okay. So how you will draw it? So you know that what is the velocity? Velocity is equal to this h omega upon phi, but it is constant. Okay. So velocity will remain constant through the complete period of either angle of rise or angle of return. The velocity will remain constant. Okay. So this way you can draw the velocity diagram. What about the acceleration? Okay. So how you will draw the acceleration? See, it is acceleration versus theta. Okay. Here you can see at this particular point. What is happening here? That initially जब cam start होता है, तो जब तो velocity zero था, ठीक है, because cam is starting movement. So जैसे ही cam start होता है, suddenly the velocity goes to this value, right? Zero to this value, that is h omega upon phi in no time. Okay. So here you can say that here acceleration goes to a level of infinity. See what is acceleration? Acceleration is rate of change of velocity. So initially velocity क्या था? Initially velocity was zero. Initially it was zero. Okay. In no moment it goes to this value. It takes some value in no time. V minus zero upon zero. Upon zero means infinity, means acceleration is going to be infinity at this point, and after that it will become the velocity will become equal, that is constant, means there is no change in velocity after that. So acceleration will become zero at the same moment. It will be like this, means its value will come down from infinity to zero, and then acceleration will remain zero till this point. At this point what will happen? The velocity will reduce from v to 0, means 0 minus v, 0 minus v upon in no time. Okay. So your acceleration will be infinity in, but in negative direction. Okay. And at the same moment it will come back to 0 after infinity to 0. So your acceleration diagram will look like this. See, ये हो गया आपका डिस्प्लेसमेंट डायग्राम। डिस्प्लेसमेंट डायग्राम में आपको सिर्फ एक लाइन ड्रॉ करनी पड़ती है, जॉइनिंग टू कॉर्नर्स। इट इज rise of the follower. Okay, it is the rise and it is the return. So during rise, the follower steadily moves from low position to top position. Okay, and during this period, the angle of rise, your velocity remains constant like this. Here there is dual period, means there is no change in displacement of the follower. So velocity comes down to zero at this point, remains zero during the dual period, and now it is returning. It is returning with constant velocity. So that's why velocity is in negative direction now, but it is constant. But direction has changed. It is now returning. So a rectangle is shown in the negative direction. It is your x-axis. Here you take positive values, okay, and downward you take the negative values. So this value will depend again on this angle theta r. थीटा आर कितना है आपका, उस पर डिपेंड करेंगे। दिस वैल्यू विल डिपेंड ऑन थीटा 0, and as I explained you the acceleration diagram, acceleration, you know that it is rate of change of velocity. So here you can say at this point that velocity velocity is changing from 0 to this value in no time. Time has not passed, angle is not there. Excuse me. So you can see here this line that there is no rotation, just start, and the velocity goes to this value in no time. So there is change in velocity, but time is 0. So acceleration will be infinity. Then after that it becomes constant. So your acceleration comes down. It comes down to 0 value and remains 0. Then again here velocity drops from this value to 0. So again negative acceleration infinity, and again it will become 0. It will remain 0. Like this you can draw the acceleration diagram. Okay. So in practice it is seen that there are so sudden changes in acceleration, 0 to infinity, infinity to 0. So because of that, what happens, that operation of the cam and follower becomes jerky. There is no smooth operation. You feel the jerks arising from the contact between follower and cam. And the definition of jerk is what, you know, what is the definition of jerk? It is a rate of change of acceleration, rate of change of acceleration with respect to time. So here you can see in no time the acceleration goes from 0 to infinity. Time is again 0. So jerk will be present in the operation. The operation of cam and follower will be jerky, not smooth. So in practice, some modification is done in displacement diagram. Because of those modifications, these drawbacks of the constant velocity motion is overcome. Okay. So it is just for your information. Also, you are required to draw this velocity acceleration diagram in your drawing sheet. Okay. If the type of motion is given as your constant velocity, same diagram you have to draw a rectangle. Now its height will depend on what is the value of velocity. वो फॉर्मूला जो हमने देखा यहाँ पे, इससे आप निकाल सकते हो. So generally you draw it of any size, okay, and tell that this is equal to this much. That is the practice. No need to take the scale for it. Okay. So it is about the constant velocity. Next we will see simple harmonic motion. So should we continue or should we continue on Saturday? I think we can cover it in 10 minutes. Yes, what is your opinion?
Continue, sir.
Continue. Okay. So we can finish this topic, simple harmonic motion. So if simple harmonic motion is given, then how to draw the displacement diagram? Okay. So again here, you draw a rectangle here like this. Its length, you can take any length, but remember that you have to divide this length into even number of equal parts. Generally we take 6 number of equal parts. Okay. Now its height, again its height will depend, its height will be nothing but your age. What is the lift or maximum travel of the follower? So accordingly you take this height. Height is not arbitrarily. Okay. After taking this, what you have to do, सेम जैसे कांस्टेंट वेलोसिटी में 6 पार्ट्स में डिवाइड किया है इसको, तो इसको भी 6 पार्ट्स में डिवाइड करो, लेंथ को. ये हो गए 2 पार्ट्स. व्हेन यू विल ड्रॉ इट विथ पेंसिल एंड स्केल, so that will appear in good shape. You number it 0 1 2, then 3 4 5 and 6. Okay. Now what you have to do here, method is different. So this particular line which is equal to h, you take it as diameter, so its center will be at the midpoint, and taking it as diameter you draw a semicircle. What it happened? Okay. Okay, you draw it a semicircle, you have to draw taking it as diameter. Now you divide this semicircle into same number of equal parts, in which you have divided this rectangle. तो ये रेक्टेंगल को 6 पार्ट्स में डिवाइड किया था, सेमी सर्कल को भी इक्वल पार्ट्स में 6 इक्वल पार्ट्स में डिवाइड करना है. तो यू नो दैट दिस एंगल इज 180 डिग्री. 180 डिवाइडेड बाय 6 मींस 30 डिग्री ईच. तो ये हो गया दो 90 डिग्री के पार्ट्स. अब ये जो 90 डिग्री का पार्ट है, इसको 3 पार्ट्स में आपको डिवाइड करना है, each one with 30 degree, 30 30 30. Here also you will divide it 3 parts. So total कितना हो गया, 6 parts. Now you number it like 1 2 3 4 5 and 6. Suppose if you are drawing for return stroke, then you will number from the top position, means here will be 0 1 2 3 4 5 etc. Okay, so we are drawing it for the rise. Angle of rise means follower is rising. Okay, so after this, after dividing the semicircle into 6 equal parts, what you will do, that you have to extend this point 1 horizontally like this up to the vertical line 1, up to the vertical line 1. So here you get a point. Then from point 2 on semicircle, draw a horizontal line till this vertical line 2. Okay, so this will be your point of intersection. Then from this point 3 on semicircle, repeat the procedure up to vertical line 3. From point 4 to vertical line 4, you will get a point. From 5 to vertical line 5, you will get a point. And 6 to 6, here you will get a point. After locating all these points, you can even number them, like here it is point 1 dash, then 2 dash, 3 dash, then here 4 dash, here okay, here you can say 5 dash, and here it is 6 dash. And after locating all these points, you will find that these points are not in a line. Okay, so you have to join them by a curve. आपको एक curve draw करना है which is passing, smooth curve which is passing through all these points like this. Remember that all these points will not be in a line, so you have to join them with the help of a curve. Okay, and it is your displacement diagram for simple harmonic motion. Okay, are you getting the procedure? Yes, पहले क्या किया, रेक्टेंगल ड्रॉ कर लिया. रेक्टेंगल का जो हाइट रखा वो इक्वल टू लिफ्ट ऑफ द फॉलोअर. लेंथ आप कितना भी ले सकते हो, तो 60 mm इज कॉमन टू टेक. फिर रेक्टेंगल को 6 पार्ट्स में डिवाइड किया, इक्वल पार्ट्स में. देन डायमीटर, दिस लिफ्ट इज टेकन एज डायमीटर एंड ड्रॉन अ सेमी सर्कल. इस सेमी सर्कल को 6 इक्वल पार्ट्स में डिवाइड किया, मार्किंग किया यहाँ पे नंबर्ड. And then from this point, horizontal lines are drawn till the vertical lines, and point 1 dash, 2 dash, 3 dash, 4 dash are located. After that, just a curve is drawn which is passing through all these points. Okay, so that is your construction of displacement diagram in case of simple harmonic motion. Now if we do the motion analysis, we can find out, determine the important formula in case of simple harmonic motion. Okay, so that part of formulae and velocity diagram, acceleration diagram in case of simple harmonic motion, we will see in the next part on Saturday. Please keep in mind, on Saturday I might continue from 10 to 1, so that our module will also be covered and your lab will also be covered completely.
So we are having FM and IE lectures on Saturday.
How many hours?
So at least one hour each.
1 hour each, na? So we can, because I have not taken this time. Your one practical is missed, unfortunately. If you want, then you give me some time, like tomorrow in night, because you people discuss about it. Because I want to cover this module in this week only, so that fourth module we can start next week. Otherwise, syllabus will not be, up to the required number of modules. You discuss it, and we will discuss more on group. Okay, and tell me वो इस ऑडिटांशो है कि वहाँ पे ग्रुप एक्टिव है ना आपका?
Yes, so
हाँ, तो आप डिस्कस करो और कल तक मुझे बताओ. अभी हम यहीं रुकते हैं. ओके, लेट अस स्टॉप हियर. You all join the mass lecture. Thank you very
okay,
much.
sir. Thank you, sir.